Okay, what we're going to discuss next is called Descartes' rule of signs. I think I'm pronouncing that correctly. It's a French name, but that's the way I've always heard it pronounced. What this is going to do is help you determine, out of all of your roots, how many of them are real, and I left out the word positive here, determines the possible number of real positive roots and how many of them might be negative real roots. Okay, so how many of them might be positive, how many of them might be negative. Now, this is just a little helpful hint on how to calculate p of a negative x that you'll need to know in just a little bit. I'm not going to get into the explanation of it just now, but just go ahead and write it down and have it in your notes. Okay, so here's how this is going to work. What you're going to do is count how many times that your signs change from term to term. So like when you compare your first two terms, this is a positive 3, and then here you have a positive 1. That's not a sign change because it's a positive to a positive. So go to the next two. So here you have a positive 1, here you have a negative 8, so that would be considered a sign change. Okay? Then you compare the next two. Well, there's not a sign change here because it's a negative to a negative. So a sign change literally means positive to negative or negative to positive. Okay? Now, once you count that up on this given problem, then this is going to determine how many of them might be positive real roots. And I counted up 1 sign change. So that means out of all of these roots, see I've got a total of 3 roots, I know for sure that one of them is going to be a positive number. That's what that tells me, okay? Now, here's where the p of negative x comes in. Now, like I said, you can go through and do all the calculations, but I'm just going to show you a quick way of doing this. So what I had you to write down, it said to change the sign of all terms with an odd exponent. Okay, so this has an odd exponent because the exponent's a 3. 3's odd. And this has an odd exponent because it's understood to be to the first power, and 1 is an odd. So when I say change the sign, that means what's in front. So instead of this being a positive 3, I'm going to make it be a negative 3. Now, this one stays. The only thing I change is what I've circled. So this will stay plus x squared. So instead of being a minus 8, I'm going to have a plus 8. And then this one stays the same. Okay, so now recalculate your sign changes. Okay, so I have a sign change from here to here because that's a negative to a positive. Now, I don't have a sign change between the next two because they're both positive, but I have a sign change here. This is going to be a positive to a negative. So here is where we're going to figure out how many of them might be negative. So negative real roots. So I've counted up 2. Okay. Now, on this situation, I'm actually going to say 2 or 0. Now, what the rule is whatever number you start out with here, you're supposed to subtract 2. So 2 minus 2 will give me 0. Now, the reason why I did not do that up here is because if I were to subtract 2 from 1, I get a negative 1. You're not ever going to list a negative number. And that's because we're talking about how many of something, and you can't have a negative amount, okay? So that means you're either going to have 1 positive, 2 negative, so that would be your total of 3. Remember, we're going to have a total of 3, so if I have 1 positive and I have 2 negative, that's all 3 of them. But I could also have 1 positive and no negatives. Well, if I only have 1 positive and I have no negatives, that would mean my other 2 are actually going to be imaginary. You remember we talked about those imaginaries being in pairs, okay? So you actually can figure out how many might be imaginary, but your question doesn't specifically ask that, okay? This is all that you're, asked to figure out from these problems. Now, on the subtracting 2, and I'm just going to make these numbers up, like if I started out and I had 5 sign changes, and you don't have to write this down, I just want to explain it. If I counted 5 sign changes, I would say 5 or 3 or 1. Like you're actually going to continue to subtract 2, but you stop before you get into your negative numbers, okay? All right, let's look at another one real quick. Okay, so counting my sign changes, positive 2, negative 1, so that's a sign change. Negative to negative would not be a sign change, but then I have 1 from here, a negative to the positive. All right, so write down positive. And I've counted up 2 sign changes, but then I have to subtract 2, so 2 minus 2 is going to give me 0. Okay, now we're going to calculate P of negative x. So your odd exponents, that's this one and this one, because your 3 would be an odd exponent. Of course, this is an understood 1 that's an odd exponent. All right, so the first term's going to stay as it is. This is going to change to a plus now. This is going to change to a plus. And that's going to stay a plus. So now if you count your sign changes up, positive 2, positive 1, positive 3, positive 7, you actually don't have any sign changes at all on this one. So as far as how many of them might be negative, that would be none, okay? So again, you wouldn't subtract 2, because if you subtract 2, that's going to give you negative 2. Don't list any negatives. So, continue to, subtract 2, but don't write down anything that's negative. That lets you know that you need to stop. So you could have, out of your 4 answers, remember this one's going to have 4, you could have 2 positive and no negative, or you could have no positive and no negative. But like I said, where the rest of them come in would be, it's possible some of them might be imaginary.